Alright, so we've looked at congruent triangles where we have to have all their parts congruent, so all three angles, all three sides. What we're going to look at now is some postulates or shortcuts that allow us to only have three pieces of information and determine if a triangle is congruent. So our first postulate, and remember postulate means something we assume to be true, is called side, side, side. Simply put, if all three sides on one triangle are the same as all three sides on another triangle, then those triangles have to be congruent. We can also have side angle side, which means if I have a side, an angle, and a side, and it's key that the angle is included, so it can't be this angle over here. So the angle between two sides, if that's congruent between two triangles, then those triangles are congruent themselves. So we're going to use those to develop different proofs. And it's really important that we don't just start trying to make our proof, that we really draw a figure, we mark it up, and we plan out our proof. So we should have an idea of what we're doing before we just start trying to prove something. So if we do that for this example down here, we have mem is the midpoint of xy. Well, what does that mean? It means that it's in the middle. Well, what does it mean to be in the middle? It means that those two pieces are congruent. They're the same. And we're also given that xa is congruent to ay. So we can see I have two sides that are the same, and it turns out that that third side, am, is congruent to itself. Alright? So I really have three sides that are all the same between two triangles, so they're going to be congruent by side, side, side. So we look at there's my first side, there's my second side, and then am is congruent to am. That's a reflexive property of congruence, and it just means that our third side is the same for both of them, which means the triangles are congruent by side, side, side. Alright? Sometimes it's going to look a little more confusing. So we can see this shape here. It's a little confusing to even see which triangles we're talking about. So one thing that we can do is we can separate them. So we pull ADC over here, and then we pull DCB over there. Now we have to keep in mind we're just having a picture here. I can't really have point C in two different locations, but it's going to help me visualize what pieces of this triangle I need to prove congruence. So we have the congruent pieces here. AD is congruent to BC. But we also have DC is on both of them. It's the same. And so if we were going to prove these congruent, what other information would we need? Well, if we had that angle included, we would have congruent triangles by side, angle, side. And further, if we had those sides, so AC and BD, congruent, we'd have side, side, side. So that information would allow us to prove congruent triangles. Right now we only have two pieces, and so we can't prove that they're congruent. If we look at the next one, again, we want to kind of pick it apart, mark it up, and see what we have. We have those angles are given to be the same. And I also have that those sides are the same. So if we think about it, right, I have side angle. If this side is the same on both of them, which it is because I share it, then I have side angle side. So we can prove this. That's going to be both having the same side length. We call that a reflexive property. And so we could prove it, and we would use side, angle, side. So that's kind of an overview of how we're going to do it. We'll have more formal proofs in a minute, but again, you want to have an idea of what you're proving before you just start trying to write it down. Alright, so in section 4.3, we're going to look at our other two congruence postulates. So there's only going to be four things in this chapter, well, really five, but four, one is a special case, four that deal with parts of a triangle, three parts of a triangle. So we have side, 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 angle, side. And then our new ones for this section are angle, side, angle, and angle, angle, side. And so what these say are angle, side, angle tells me that if two angles and the included side of a triangle are congruent to the two angles and the included side of another triangle, then the triangles are congruent. So what that means is if we look at the angle and the side, the other angle is what's included in it. And so it has to be that this side is touching both of these angles, and it's the same relationship for both triangles. If we have that relationship, then they're going to be congruent triangles. So if we look at the three triangles up here, right, we're going to try to determine which of them are congruent by angle, side, angles. Let's just mark what we have. Let's color in a little bit. So I can see that that is our congruent angle there. They each have a congruent angle that I marked in green. And what the key difference is going to be is where that side happens. So we can see that these two triangles, right, are matched up exactly the same with angle, side, angle. while this has two angles and a side, they're not included. This red angle would need to be over here at point F. And so when we name these triangles, we need to make sure that we have the corresponding parts match up. So if I say triangle CAT, right, I look for in my triangle what matches with C. Well, C matches with G. So that starts with G, D matches with A, and O matches with T. And so even though it's tempting to say cat is congruent to dog, the way that these are labeled, that's not true in this case. So now we're going to kind of dive into a full-blown proof here. So we don't have any statements or reasons. We have to fill it in given this information. So again, we're going to mark up the diagram and then try to flesh out our proof after that. So we've been given a couple of things, that A is congruent to B, and we also know that those angles are vertical, so they're going to be congruent. So we're getting pretty close. And I know that AP is congruent to BP. So I can see here that I have an angle, a side, and an angle a side, and an angle, so that's going to be enough to show these are congruent. So now I need to write it down and show all the steps. So I start with my givens, just as we did before. So those are my given information, right? I also have APX is congruent to angle BPY. Those are my angles in here, and the reason that that's true is because vertical angles are congruent. All right, and from that information, I can say that APX is congruent to triangle BPY, and my reason for that is angle, side, angle, and that allows me to show that those triangles are congruent. So we have another theorem, right? This one is very similar, but it's angle, angle, side. And so if that has that relationship, angle, angle, side, as we see here, angle, angle, side, angle, angle, side, then the other triangles are going to be congruent. And so again, we have another proof that we can develop. And so let's mark it up first, and then we'll try to write it down and see if we can understand it. So I've been given, in this case, we'll look at above here, that's my relationship exactly as it is. And in my proof here, right, I'm going to mark that because I can see really here that I have two triangles that have been squished together. So AC is going to be important to both triangles. And I have some parallel lines. Well, those angles are alternate interior angles, which are congruent from our previous chapter. So right now I have a side, right, an angle, and I have another angle over here. Now the order, though, is angle, angle, side. And so I'm going to be able to show that these are congruent by angle, angle, side. So if we flesh that out, again, I start with my given. That allows me to start my proof. And then I say BAC is congruent to angle DCA. All right, so BAC, right, that's my alternate interior angles. So my reason is alternate interior angles are congruent. And now I can state that these triangles are congruent. Or I'm sorry, I have AC is congruent to AC. So that's the side that they share here. And our reason for that is the reflexive property of congruence. This means it's congruent to itself. And so now I have angle, angle, side. I have that relationship. I can conclude that my triangles are congruent. And from there, my reason is angle, angle, side. All right. All we have for the rest of the chapter is we're going to see here we use corresponding parts of congruent triangles, but the key things are what we just talked about are side, 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 angle, side, angle, side, angle, and angle, angle, side.